So we're going to take a moment and talk multiplying and dividing with mixed numbers. This can get a bit tricky, but the fun part is as long as you understand the multiplication piece, you will get division for free, basically. And I'll talk about that in just a moment. So, for example, I could have a 1 by 1 square, right? And you could imagine, let me zoom out just a little bit. You can imagine making the square that would fit in, that is 1 unit long, 1 unit tall, and you can imagine a square going all the way across. Now, suppose I asked for, and I took 1/2, right there, and I took the other one, actually let's just go 1/3, just to mix it up a little bit. Suppose I gave you the other 1/3. So I'd have 1/2 times 1/3. Well, here's what I want you to think about. My 1/2 splits my box in half. No doubt, right? So if my 1/2 splits my box in half, and my 1/3 splits it into thirds, when I have 1/2 times 1/3, multiplication makes sense in this case because we essentially have area base times height. So when I have that 1/2 times 1/3, we'll think about what the whole would be. The whole would be all of these spaces, or 1, 2, 3, 4, 5, and 6 of them. But guess what? I don't want all 6. I just want this one right here. That 1/2 times 1/3 will give me 1/6. So when we are multiplying fractions, it is as simple as going straight across. So to try another one, if I gave you 2/5 times 3/7, all we would do would be to multiply straight across. So 2 times 3 will give me a 6 on top, and then 5 times 7, go and think about that for a second, will end up being 35. And so this right here is equivalent to 6/35. Okay? So if we want to take advantage of that multiplying straight across piece, then all that means is we need to be able to turn a mixed number into what's called an improper fraction, where it has no whole number in front. So consider the following. Embrace my inner Bill Nye the Science Guy with that one. If I have 1 2/3 times, we'll go 3 1/5. Okay. I need to write these without the whole number. I need to write these not as mixed numbers, but as improper. So I've got the 2/3 piece, and I also have 1 whole. So the question becomes, what does the 1 whole turn into if I want to write it in terms of threes? Well, that 1 whole is the same as 3/3. And I'm going to add that to my 2/3. So that means that the 1 2/3 is the same as saying 5/3. Keep the denominator, add the numerators together. I'm going to do the same thing over here. If I want to rewrite that 3 with a denominator of 5, then that means that every whole has how many 1/5 in it? Well, every whole is going to have, that's a 7. Here we go. Every one whole is going to have 1, 2, 3, 4, 5 fifths in it. So that means that if I have 3 of these wholes, then how many fifths do I have? 5, 10, 15 in total. 15 over 5 is the same as 3. I'm going to add that to the 1/5 at the end. So now 15 plus 1 gives me 16 over 5. Again, when you're adding fractions, the denominator stays the same. Now, since they asked me to multiply, I just brought the multiplication symbol all the way down. All I got to do is go straight across. 3 times 5 will give me 15 for the denominator. And then in terms of the numerator, 5 times 16, might need to show some work for that. So 16 times 5, 5 times 6 will give me 30, 5 times 1 is 5, but then I need to add my 3, so I get 8. So I get 80 over 15. Now it does turn out that that simplifies. I'm okay with this as an answer for right now. You could recognize that 5 goes in the top and the bottom, in which case if you were to take out that 5, you would end up with the answer 16 over 3. But for our purposes, even if you just got to this point, we're heading in the right direction. Okay? Now, division piece, I realize I'm kind of doing a lot, but I'm hoping this kind of helps you play around with stuff. And do take some time, just play around with these guys. Start putting different pieces together. Even if you're doing a problem where you're like, I don't know, still just kind of model it by going together, because it can be helpful. Suppose I had a division piece. So suppose I did, what would be a good one? Let's go 1 and 1/4 divided by 1/6. Okay, here's where it gets kind of tricky with division. We can build this one. So here's the 1. Okay, I'm going to come over here and find a 4th. Let's go ahead and fold this guy over. Here's my 4th. So this right here represents my 1 and 1/4. Okay, I've got the 1 going straight across and the 1/4 just after. And I'm going to go ahead and make the realization that I know that that 1 piece is equivalent. Where's my other 4th? Where's my 4th? Here we go. I'm going to make the observation that that 1 and 1/4 is equivalent to my 4 out of 4. So I'm going to go ahead and just slide and replace this. So that means that I know that that 1 and 1/4 is the same as this piece right here, the 1 and 1/4, is the same as 5 over 4. Okay, hopefully that's a pretty easy switch. We're just replacing equivalents of 1. Now here's the question though. They're asking us to divide this by 1/6. So let's think for a second about 1/6 and what it means. This division step is asking me how many times will 1/6 fit into this line. And we can kind of build that with our fraction bars, right? We know automatically that on the 1 piece, I'm going to get 1, 2, 3, 4, 5. I'm going to get 6 of those. And then I know that if I take my other 1/6, I'm going to get a 7th one. And then I'm going to get some extra little piece. But I'm not 100% sure what that extra little piece is. And so it's kind of tricky to think about, okay, well, what happens here in terms of how much do I need? Well, it turns out when you're dividing fractions, there's a really helpful pattern to keep in mind. And that pattern is this. Keep change, flip. So here's what I'm going to do. I'm going to keep my first fraction, 5 over 4. I'm going to change division to multiplication. And then I'm going to flip my second fraction, 6 over 1. And it turns out that if you do this, you will be able to figure out what your final answer is in terms of how many of those 1/6 would have made up that initial line. So if I take advantage of this, multiplying straight across, 5 times 6 is 30, 4 times 1 gives me 4. So you can leave it like that. You can recognize that you can take a 2 out of top and bottom, in which case you would get 15 over 2. Or you might even recognize that if you simplify this, how many 2's go into 15, you would actually end up with 7 1/2. You might also think about it as being 15 over 2 is 14 over 2 plus 1 over 2, right? 14 plus 1 is 15, and then 14 over 2 is 7. So you kind of have some different ways that you can think about it, but let's see how that fits in with what we had here. 1, 2, 3, 4, 5, 6, 7, and my cutting's not perfect, but that's pretty close to a half right there. And so it does kind of check out. And so visually you can get an idea of what you can expect. So again, take the strips of paper, fold them around, represent different problems. Remember, anytime you have a whole number mixed fraction, you can turn that whole number and convert it into improper. So that would be like turning the 1 1/4 into 5/4 instead. When you're adding and subtracting, you can kind of place them to get an idea. When you're multiplying and dividing, multiplying you go straight across, division, keep, change, flip. So take some time to play around with them, representing different problems. I might have should have kept some of the numbers a little on the smaller side, but I think you can dabble with it pretty well. Give that worksheet a try with some of the different ones, and yeah, we'll see how it goes.